Hi, this is Halal. In this video on Mathematical Economics series, we will discuss about the input-output analysis. So we will give a brief intuition about the input-output analysis. Okay, now we know that in a modern economy, where the production of one good requires the input of many other goods as intermediate goods. That is, we take a simple example. If we have an economy, we know in an economy there are multiple industries as we know. Now for the sake of simplicity, we take an industry. Let us say we have a steel industry. Let us say we have steel industry. Now we have other industry. Let us say we have steel itself, steel industry, iron industry, and electricity industry. Now we know that in any economy, that is to produce some steel, we require the steel. That is, if we are producing the steel, some output will be internally consumed by the steel industry. Similarly, this steel industry will sold some of its output to the iron industry. So iron industry will also use some output from the steel industry. Similarly, we have the electricity industry. This industry will also require some input from the steel industry. So all the industries are internally connected with each other. Similarly, if we have the electricity industry, some of its output will be internally consumed by the electricity industry for the power, for the lights, and so on. Similarly, this electricity industry will sold some of its output to the iron industry. So iron industry will use the output of the electricity industry, and in the same way iron industry will give some of its output to the steel industry, to the electric industry, and some will it consume internally. So the basic intuition is that output of one industry is used by the other industries as well as by the industry itself. That is, output used output of one industry is used by other industries as well as by industry in itself. Let us take a simple numerical example. That is, if we have a steel industry, here I write steel, we have the coal industry, and we have the electricity industry, and here we have also these industries. This is steel industry, coal industry, and electricity industry. Okay, now steel industry will produce some output which is used by the steel industry itself, by the coal industry, and by electricity. Apart from that, some steel will be demanded by the consumers, that is by the household sector or by the government sector or by the exporters. So we have another column here which is the final demand. That's called final demand. So this final demand will come out from the consumers. This will come from the household sector or the government sector or from the export sectors. That is, some part of steel will be used by the steel industry by itself, and some of its output will be sold to the coal industry, some to the electricity industry, and some will be demanded by the households or government sector or electricity sector. So this is same true for all the industries. Let us say that steel industry sells 6 units to itself. Okay, similarly the steel industry sold let us say 10 units of output to the coal industry. Similarly the steel industry sold some part of its output to the electricity energy. Let us say this is 12, and let us say some part is demanded by the that's final demand, which is demanded by the household sector, government sector, or export sector. Let us say this is this comes out to be any number. Let's say this is 14. Now total production will be, so here we have the total output or total production. So I will align this page here. Therefore total output. Now this total output will be the summation of all these industries, that is 6 plus 10 plus 12, and the final demand. This comes out to be 6 plus 10 plus 12 plus 14, which will be 42. That is total output produced is 42. Similarly, let us say coal industry sells steel industry 8 units of coal. Similarly, coal industry sells coal industry, that is the internal consumption, that's 2 units of coal. And coal industry sells electricity energy, electric industry, let us say 9 units of coal, and some part of it is demanded by the household sector, or which is called the final demand, or the government sector. So let us say this is 9, or let us say it is 11 units. Okay, therefore the total output sold out to all these entities comes out to be 11 plus 9 plus 2 plus 8, which comes out to be 30. Similarly will be the electricity industry will sold some of its output to the steel industry. Let us say it sells 2 units of electricity to the steel industry, and similarly this electricity industry sells coal industry, let us say 1 unit of electricity. And let us say electricity industry sells electricity energy, that is the internal consumption, 2 units. And some part of the electricity will be demanded by the household, government, or export sector. Let us say this is 2 units. So I am just taking a hypothetical example here. Now here this will be also come out to be 2 plus 1 plus 2 plus 2, that is 7. Now here it's to be understood very clearly. Here this particular row, this row is the number of units sold by a particular industry to other industries. That is this particular row, or any particular row, will show the number of units sold by a particular industry to other industries, as well as to the final demand. That is this row will show that steel gives 6 units, steel gives coal 10 units, steel gives electricity 12 units, and steel gives the final demand 14 units. So particular row is always the number of units sold by any particular industry to other industries. So here if you can visualize here, the units will be same. So we are here able to add up these all elements, which comes out to be 42. So here the units are same, here are the same units, same steel units. Similar cases for the other rows. That is, coal unit coal industry gives 8 units to steel, 2 units to coal, and 9 units to electricity, and 11 units as final demand. So we can add up this row also, because here also the units will be same. And similarly, the electricity energy will give 2 units to steel, 1 to coal, 2 to electricity, and 2 is demanded by the household, government, or electricity center, and it comes out to be 7 units. Okay, so particular row always shows the number of units sold by a particular industry to other industries. But here it is to be seen, we can see it clearly, that this particular column will not have the same units. How? Because particular column is the total number of units consumed by a particular industry from the other industries. That is, this column here is the number of total number of units consumed by this steel industry from other industries. That is, steel industry uses 6 units from steel industry uses 8 units from coal industry, and steel industry uses 2 units from electricity industries. Here I was able to add up, because here the units were same. Let us say that were in kgs, but on this column wise we can't add up here. We cannot add up here. Why? Because there can be, the steel could have, let us say it has the units in kg. Let us say the coal could have in liters, or here, sorry, I will write in grams. And electricity cannot be sold out in kgs, as we know. This can be in the volts. So we cannot add up the columns here, because columns could have the different units, but any particular row will have the same unit. So this column shows purchase of inputs. That is, column and denotes, column shows purchase of inputs, and the row shows the sale of outputs. That is, these rows shows the sale of outputs to various entities here. So I will write here row shows sale of output. So I'm just giving the theoretical idea how it's done. In the next video we will see the mathematical interpretation. I hope I am making myself clear. Now, after we are familiar how the industries are interrelated with each other, or interdependent on each other. That is, particular row, every row and column are dependent on each other. Okay. After we have formed this table, we have to form the input output coefficient matrix. That is, we have to form input coefficient matrix. Now, how it is done? This input output coefficient tells us to produce 1 unit of output, how much units of other units are required. That is, to produce one unit of output, how much, that is, how much units of other industries required. So this input output coefficient gives us the per unit output per unit worth of output. Okay, now how it is done? Let us take a simple 2 by 2 matrix. That is, we have only two industries. So I will write how to form the coefficient matrix. Let us say we have the steel industry. I will write here steel and electricity. Here we have steel and electricity. Okay, and we have some final demand. Let us say steel sells 8 units to itself, and steel sells 12 units to electricity industry, and steel sells 10 units to the consumers or householders. Similarly, let us say electricity and industry sells 7 units to steel industry, and let us say electricity and industry sells 11 units to itself, and electricity industry sells, let us give some number here. Let us say it is 9 units to the consumers or household sector or government sector. Now, as we have here added up the total output, so here we will write the output, that's total output. Total output would be 10 plus 12 plus 8, that is 10 plus 12 is 22, 8, that is 30. Similarly, 7 plus 11 plus 9, that comes out to be 27. Okay, so we have to form the technological matrix, that is the input output coefficient matrix. Now how it is done? So I will write here again this very, to form the input output matrix. I write here steel, this is the steel, this is electricity, and here we have steel. So I will write here it steel and electricity. Okay, now we have to see, to produce 1 unit of output, how much units of other industries are required. That is, we have to show the per unit worth of output. That is, here if you can visualize, here 30 units of output require 8 units of steel. That is, I will write it here, that is so I will write here I will try to summarize it here. 30 units of output requires 8 units of steel. That is, 30 of output requires 8 units of steel. Now, 1 unit, to produce 1 unit of output, we require 8 divided by 30 units of steel. That is, we have to form the input output coefficient, which shows per unit worth of output. So it is very easy to visualize. That is, if 30 units require 8 units of steel, then 1 unit of output will require 8 divided by 30 units of steel. So here this will be 8 divided by 30. Similarly, to produce 30 units of output, we require 7 units of electricity. That is, I will write here, to produce 30 units of output, we require 7 units of electricity. Then to produce 1 unit worth of output, we require 7 divided by 30 units of electricity. So here this will become 7 divided by 30. Remember, here we are taking the per unit worth of output. Okay, or we can say it is the percentage of steel required for 1 unit of output and percentage of electricity required for 1 unit worth of output. Similarly, for this electricity industry, we can see here, since its output is this, electricity output is 27. Now 27 units of output requires 12 units of electricity. Then 1 unit of output will require 12 divided by 27 units of electricity. So I will write here, this is 12 divided by 27 by the same logic here. So I will write here for the sake of simplicity, that is 27 units of output requires 12 units of electricity. Therefore 1 unit of output will require 12 divided by 27 units of electricity. So here this will be 12 divided by 27. Similarly, this 27 outputs require 11 units, then 1 output will require 11 divided by 27. So I will write here, it is 11 divided by 27. So this is our technological matrix. This is our input output coefficient matrix, which shows to produce 1 unit of output how much units of other industries are required. So I hope I am making myself clear to you. Now coming to another point on this topic. Now we know that any industry, let us say we have industry, any industry, first of all, if any industry is producing some output, some of its output is used for self-consumption. So some is consumed by the industry itself, and some of its output is sold to the other industry, as we have seen in this example. So other is sold out to the other industries, and this industry gives some of its output to the households or government sector, or to the exporters, whatever you say. Okay, now this self-consumption and the other industries output, which is giving to the other industries, this is called internal demand. And this is called the final demand. Now internal demand plus final demand will give us the total output. So this is the total output. Here I will write here, this will be total output. Now this internal demand in matrix form is denoted by, let us say the total output produced is X. We say total output produced is X. Okay, and let us say the final demand is D. We denote the final demand by D, that is the demand from household, government sector or exporters. Plus then the internal consumption will be equal to A into X. It is here to be understood. So this is how we depicted this the industry's input and output. Now this A is the technological matrix, that is per unit worth of output times the number of output we have to produce will give us the internal demand. So here it's to be if I can make myself here clear, here this, let us say this is the input output, this is the per unit worth of output. If I say let us say we have one pencil, let us say one pencil is equal to 10 rupees. Therefore, to produce 5 pencils, we require 10 into 5. 10 into 5. So this A is the per unit worth of output. Since we have to produce the X units, then we multiply this per unit by the number of output to be produced. So this AX gives us the internal demand. So A is the this A is called the Leontief matrix also. So I will write this is called the Leontief matrix. Now this A I have seen, this is the per unit worth, that is per unit worth times the number of times the output gives us the internal demand. This D is the demand from the household sector. So this plus this will be equal to the total output. So this is called Leontief matrix or technology matrix. So I will write technology matrix. So this is the final demand, and this is the total output. Now we have some conditions, that is we can manipulate this. If this is AX plus D is equal to X, now I can write this as X minus AX, that is X minus AX is equal to D. Okay, now taking X common, so taking X common, we are with this I minus A is equal to D. Now this I is the identity matrix, because this is as we have seen in the earlier videos, this is AX plus B type, which we use in the Cramer's rule, or how we express the equations in matrix form. So these are all depictions of matrices. So this is here the identity matrix, this is the technological coefficient. Okay, so I have manipulated it here. Or we can write X is equal to I minus A inverse times D. So this is how we find the required output. Now there are some conditions. First condition is that this is called, this I minus A, this is called Leontief matrix. Actually this is called the Leontief matrix. Sorry, I have written here this A. This I minus A matrix is called, this is Leontief matrix or technology matrix. Okay, now the conditions are, these conditions are called Hawking-Simon conditions, that is Hawking-Simon conditions. Now what are these? First condition is that the determinant of this I, that is I minus A, it should be positive, or it should be greater than 0. First condition of Hawking-Simon condition, Hawking-Simon, is that this the Leontief matrix, its determinant should be greater than 0. And second condition is that diagonal elements of this I minus A matrix should be greater than 0, that is diagonal elements of I minus A matrix A matrix should be greater than 0. So this is all about the input output analysis. I have given simply an intuition how it is done. So I will repeat here. If we have an economy, there are multiple industries, and every industry depends upon other industries for its input. I took a simple analysis. If we have the steel industry, and we have iron industry and electricity industries. Steel industry will consume some of its output to itself. It will give some of its output to the iron industry, some to the electricity industry. That is, output of one industry is used by other industries as well as by the industry itself. Now I took this hypothetical example, how we visualize, how we comprehend the input output table. So here it is to be remembered, although we can add across a row, but we cannot add across the columns because of the simple fact here on the row there are the same units, but on the column there cannot be the same unit. So we cannot add up vertically, although we can add up horizontally. After that, we are given this input output demand. We have to form a input output matrix which I have formed here. After that, we have to check the two conditions that are called the Hawking-Simon conditions. That is, the Leontief, the determinant of the Leontief matrix should be greater than 0. If it is not, then the system is not viable, and the diagonal elements of the Leontief matrix should be greater than 0. That is, these are called the diagonal elements. The elements on the diagonal are called the diagonal elements. So in the next video we will give a simple example, simple numerical example, and after that we will give the mathematical analysis of this input output model. I hope I make myself clear. Thank you.